Okay, so now we're going to pick up on solving log equations. We have a couple more examples here. In part C, I see some logs, and this time we have a coefficient out in front. Okay, so the 3 is one thing that I can deal with right away because I know that coefficients can come inside the parentheses as exponents. So I'm going to have the log base 2 of x minus 1 cubed plus the log base 2 of 4 has to equal 5. Okay, now we have this plus here. We need to combine these logs together. So we have the log base 2 of x minus 1 cubed times 4 equals 5. Again, I'm trying to use the properties of logarithms from section 4.5 to rewrite these two logs with a coefficient in one log with no coefficients. And the reason why I wanted to do that is now I can use the fact that the log function is one-to-one. It has an inverse. I can apply its inverse, the exponential function with base 2, to both sides because we have now cancellation on the left. Therefore, we have the equation x minus 1 cubed times 4 equals 2 to the 5th. Okay, not 5, 2 to the 5th, which is 32. Okay, this is a cubic equation, not a quadratic equation, so I need to think carefully how I would like to solve it. I realize it's essentially already in factored form, so I should not multiply everything through. I can actually do something similar to the square root method, but with a third root, okay? So the first thing I'm going to do is divide both sides by 4. Once I do that, I would have x minus 1 cubed equals 32 over 4, which is 8. Okay, so now to get rid of the third power, we apply its inverse function, the third root, to both sides. This cancels the powers. And so we are left with x minus 1 equals the third root of 8, which is 2. Just add 1 to find that x equals 3 is the answer. And then we just go and check and see if we're allowed to put 3 in for x. So I go to check, I have 3 log base 2 of 3 minus 1 plus log base 2 of 4. It's good, it's defined. So this is the log base 2 of 2 cubed plus the log base 2 of 2 squared. So this is 3 plus 2, which is 5. It checks out. You don't actually have to go all that far. You just have to make sure that at least this number is positive, okay? But it never hurts to check our work more. Okay, let's see example D. Oh no, now you see two different bases. This one has log base 2 of x plus 1 minus log base 4 of x equals 1. So we cannot just bring them together in one log because we have different bases. We have to use the change of base formula first. So please review. Change of base formula, which we had obtained previously, which states that the log base A of m is equal to the log base B of m over the log base B of A. Okay, so normally when we change base, we have to choose which base to change into, and I suggest that you always change into the smallest base present. So here we have a base of 2 and a base of 4. So we will change the base of 4 into base of 2 so that everything is in base of 2. So when I have the log of base 4 of x, that means that A is equal to 4 and m is equal to x in my formula. And keep in mind, I'm trying to change to base of 2, so B is going to equal to 2. So this is the same as the log base 2 of x divided by the log base 2 of 4. And we know that the log base 2 of 4 is equal to 2. So this is 1/2 log base 2 of x. Okay, we had to do all that before we can even start. So substituting in, we have log base 2 of x plus 1 minus 1/2 log base 2 of x. Now it looks like the previous problem. So we can take the 1/2 up into the exponent. So this will be the log base 2 of x plus 1 minus the log base 2 of x to the 1/2. And now we can take the two logs into 1, noticing carefully that we have subtraction, which will turn into division. So I have the log base 2 of x plus 1 divided by root x. And this is all equal to 1. That never changed. All I've been doing this whole time is rewriting the left-hand side. But when I want to get rid of the log, I still have to apply its inverse function, which is the exponential. So I'm going to take 2 to the power on both sides to cancel the log and get the x out from inside the parentheses. So what I'm going to have is x plus 1 over root x equals 2 to the power 1, which is 2. Okay, so a couple choices how you want to solve this. I'm going to multiply both sides by root x so as to cancel the denominator. Then I will have x plus 1 equals 2 times the square root of x. And to get rid of the square root of x, I will like to square. But if I do something to one side, I must also do it to the other side. So I'm going to FOIL the left side. X plus 1 squared equals x squared plus 2x plus 1. And 2 times the square root of x squared equals 4x. Finally, a quadratic equation. Let me just put it into standard form by subtracting the linear term 4x from both sides in order to get 0 on one side. I will have x squared minus 2x plus 1 equals 0. And now I may try to factor, or I can always use the quadratic formula. I'm going to try to factor. This is x minus 1 times x minus 1. And so I can just take the square root on both sides to get my answer, x equals 1. Let me go and check and make sure that 1 is allowed to be plugged in. 1 plus 1 is 2, and 1 is also greater than 0. So it checks.